Be good for a
Okay.
YouTube channel.
Yeah. There you go. Just upload it.
I'm
Okay, so
videoing right now.
we have about 40 milligrams here of the step 1 product, right? So she's weighed that out in a Teflon coated centrifuge tube. Really biology.
Do we always need 40 milligrams? It doesn't matter. We just need
40 milligrams tends to work pretty well. So if you have, let's try it. And if it doesn't dissolve when you put the first amount of solvent in, we'll increase a little bit, right? This is going to be pretty concentrated though, because this is 40 milligrams of solid, and I'm going to add, for step 1 only, I'm going to use the deuterated chloroform. I'm just opening this guy. So,
but I should still be able to see my peaks.
pause the video for a minute for sure.
Here's the
This
pen.
might take a while. Dr. Morton, do you know by any chance how to break this open and crack open the light line?
Don't do that. That'll get all wet. So, actually, that is a.
We should use a syringe, right?
Yeah. Yeah,
Can you
because
keep that open?
maybe. Nope.
Did I tell you
You
that?
don't want to do it and splash it all over me. So yeah. Let me.
Are we gonna have to like crack
Okay.
open?
We're gonna have to track through it. Is what we're
Do
gonna
you
have to do.
have?
I don't even know my tools on me. So.
Okay, I'm gonna do a demo really quick, and then we'll figure this out in particular. Okay. Okay, so for the following steps, instead of using the chloroform, we're probably going to use either deuterated methanol or dimethyl sulfoxide, DMSO is what we refer to that as. DMSO is an incredibly powerful
So it's running right now.
solvent that will pretty much dissolve most anything.
done.
But all 3 of these things
That's the thing.
do not have
What you're
TMS
seeing
in
at the
there
top
right
is
now.
actually the signal.
Do you remember what TMS is?
So we get to
Tetramethylsilane, very good.
Now, there's nothing there. This would sort of
Okay, so
be oscillating
tetramethylsilane, right here.
oscillation.
This guy is basically the chemical that you're adding that's unreactive
That's your actual
to your
structure. So you
compound.
saved it.
Should be.
Make sure you save it.
You're adding it into
Because
the
we're
solution
pulling it up on
mixture
supplements.
to give you where 0 is. That's what we universally set as 0 in an NMR. So that's exactly what you want to add. You want to add sort of like 1 drop of this, and actually we already have it even sort of dissolved. So this is TMS and DMSO. So 1 drop of this guy even. It doesn't take very much. Okay. So once you then have your sample, and we're going to assume that that's the sample for now. I'm actually going to run acetate. So these are our picospins. This looks absolutely nothing like what a real NMR looks like. Because, well, a real big NMR, a real nice NMR. One that you'll see probably off this campus, let's put it that way. Most NMRs, if they're what we call cryomags, they're big, huge types of things. For example, I was at Abbott Labs once. They have an 800 megahertz. This is 25, I think. 800 megahertz, yeah, NMR. That 800 megahertz NMR, there's this ring that is painted into the floor for like 4 stories. If you go beyond that ring, the magnet is so powerful, it will swipe your credit cards, it will swipe the memories in your computer, and if you have some type of heart pacemaker, you die. It's gone. That's a big magnet. This one not so much, but don't go and like lay your credit card on top of it while you do this, you know? Just try not to actually really mess with the instrument too much.
We have the benzene.
Okay, if you see that these things are sort of blocked off and loaded so that there's no injection ports, you got to take those out and put in sort of like as we see it right here, okay? So I'm going to take your sample, so assuming that this is the sample, and you pull up whatever you've got. So it's Nurse Jackie time, right? And I usually just take a chem wipe, and you gotta tap, right? And I'm trying to get the bubbles out. So you'll see that like there's no bubbles left, and I can do it this way, there's no bubbles left, right? But basically you can like see that there's going to be a little bit of liquid in there, and then you push some out. your bubble comes
Okay.
out.
But
You gotta make sure the bubble trap.
There's your NMR. Actually looking pretty good.
Then you take this injection port and you're gonna unscrew the silver part just slightly, okay? And I'm going to put
Okay,
this
so
in
the
until
red
I
one we
feel
want.
mega resistance, okay? So I can't push that anymore. Important, screw that back down. Otherwise, all the liquid's just gonna come shooting right back out at you.
So once again, why are we
This takes
overlaying
now
on
some
that
pressure.
spectrum?
This is the exit valve.
I took it off.
Yeah,
So we're gonna push this in, and it's harder than it
I like
looks.
this one.
And you can't do it too hard, because if you do, then it's gonna again pop the top off, and it's gonna come spitting out at you. But you have to give it enough pressure to actually push it through. You're doing over here, your sample is going to consist of the 40 milligrams of your sample and 200 microliters of
Now you're
your
gonna be coming over
solvent.
there.
I guess I didn't say that earlier. Then one drop of
Once you
something
need to
else.
make sure you clean the
So
IR off.
that's pretty viscous,
So,
because that's a
clean
lot,
that surface
right?
off. You need
Okay,
to
so
make sure
I've
the acetone
unscrewed this to
is
pull out the syringe, and then I re-screwed it back in. If you are using a syringe where your sample is, you then want to rinse it out with acetone as you proceed. Okay. So now we're going to go over here, and this is the interface that you're going to use to run your sample. There's really only one parameter that you ever need to change, and that's the number of scans. And the first time I do this, I wanted just to take one pulse to tell the NMR even where to look for stuff, right? So I'm just going to say I want one pulse, and I'm going to hit start run. And then you just say, oh wait.
This should basically be that whole segment.
You can also change this.
So the next thing is liquids in this. This can help show if it was the solid, we have to dissolve the solid.
Change the run name too, I'm sorry. Okay, so I'm going to hit start.
The NMR active. So what we have is a series of
And it is
that
off
will be NMR
and done.
because they're
Okay.
based.
That's how easy that was to take the first
So
scan.
that would be
You obviously have a lot of
inject.
peaks here. That's good.
Yep.
But you see how noisy this is?
We have to
All that
dissolve.
stuff, right?
So,
This is a
that'll
pure
probably
liquid.
set
It's
the
not
joint
like this has your
Okay.
compound in it that has to dissolve. Well, in this case, maybe I'm going to run just a few scans, maybe like 16 scans. For your product, I found that 100 is pretty good. That's about 7.5 to 8 minutes of run.
Okay.
So
You're
that's
right.
why it takes time to get through these. It will take time to get through these.
Yes, so you're gonna-
Once you have your
You're all
data
done with this one.
done,
So you got your spectrum.
you're then going to hit
Unless you guys wanna
download
come
data,
on, you can do your IRs later,
and then
or
you
try
have
this
to do
thing.
a save as from the bottom.
Well, I really actually did it. Just
You're
so you
going
can
to save
see
it
So you're
in.
Okay.
I've got my
Because they're all on
own.
our good side.
Let's see where I
Okay.
put it.
So I'm going to send a file. We'll be right back. Excuse
There's
me.
a Paredes sample right there. Okay. So I'm going to hit save. And I'm going to minimize the screen. Please don't exit out because it's hard to figure your way back out there. This instrument is not connected to the internet as it should be. We're going to go into MNOVA because that's what's going to allow us to analyze, and we're going to go and open that file. So I'm going to go back to, where is the desktop? Open that, and bam, there we go. Now, this is a huge range, right? You're used to seeing what range with an H&MR?
0 to 7.
0 to 7, really 0 to 12 is really max, 14 maybe. So we're gonna zoom in, and it's the little eyeglass that says plus on it. So I'm gonna zoom in, and I'm gonna just look at this area. And you can do that again.
Can we move forward so my people can get back to the instruments?
Thank you. And this is what our sample looks like. Now, I don't have TMS in here, and you can tell that this is a one run type of thing. I'm going to assume that might be a little bit of TMS. Let's say that it is. I'm then going to go to where it says reference when I scroll over it. That reference, see how I can just like go to whichever peak I want? I want it to say this peak right there. Let's say that that's TMS. I'm going to set that to 0 and hit OK. And you see how that just happened? That just set it to 0.
Problem there.
For integration and identification of peaks, there's this wonderful button right there that'll kind of just do it all for you.
Which one?
It's right there. Now, if you want to manually do that, feel free. It's a little bit, so there's also buttons up here that do that. There's the integration. There's peak pick somewhere. I'm not sure exactly where that is right now. You can use that and try to, I don't know, look at the help documents. There's plenty of documents in here if you want. But that's basically it. Now you just print it. There is a toggle to the printer. So if you need to hit the button here, go ahead and do that. But yeah.